Next, a pocket recognition operation is defined to perform finishing of the walls and floors that exist in the enclosed pocket areas. In the SolidCAM Manager, right-click the operations header and choose Pocket Recognition from the Add Milling Operations submenu. The Pocket Recognition Operation dialog box is displayed. This operation enables you to recognize the pocket features on the solid model and perform the machining of those features. On the Geometry page, click the New button to define the machining geometry for the operation. The automatically recognized geometry consists of planar faces and loops of through pocket features. The definition of the geometry is performed in the Select Faces dialog box, as you can see here. Using the default selection filter options and the selection mode of Solid Body, pick on any face of the target model in the SOLIDWORKS graphics area. All planar faces are recognized with the surface normal vector oriented parallel to the z-axis of the current coordinate system. The through pocket area is recognized according to the through pocket option. Located at the bottom of the Select Faces dialog box is a list of all the recognized model elements included in the geometry for the operation. Each model element is accompanied by its z-level value enclosed in parentheses. When an element is selected in the list, it is highlighted on the solid model. When the Select Faces dialog box is confirmed by clicking OK, SolidCAM automatically generates a number of pocket contours to perform the optimal machining of the selected faces and through pocket. After the geometry is defined, it can be shared between several pocket recognition operations. In each operation, SolidCAM enables you to perform a specific geometry modification. The modification is relevant only for the current operation and does not affect other operations based on this geometry. For the purpose of this exercise, click the Modify button to display the Geometry Modify dialog box, which enables you to define the parameters of the geometry modification. For this operation, enable the Exclude Top Faces checkbox. When this option is selected, the recognition of pocket features is not performed on the top model faces. As you can see in the list of geometry elements, the top face is now excluded from the geometry of the operation. Click OK to confirm the geometry modification and exit the Geometry Modify dialog box. Switch to the Tool page and click the Select button to display the Part Tool table. From the list, choose Tool number 3, the 6mm end mill. Click the Select button to exit the Part Tool table. Switch to the Levels page to define the machining levels of the operation. Click the Upper Level button, and in the SolidWorks graphics area, pick on the top face of the stock model as shown. Click OK to confirm the selection. It is important to note that the pocket depth is automatically recognized on the solid model for each pocket feature separately. Switch to the Technology page to define the technological parameters of the pocket recognition machining. For this operation, most of the default settings are used with the addition of some other options. Enable the Final Cut checkbox. When this option is selected, only the finish path for the floor area of the pockets is generated. In this case, the final cut on the floors will be performed first using a contour pattern with the tool having a minimum overlap of 50% of the tool diameter. To have this same operation then perform finishing of the walls, select the Wall checkbox in the Finish section. Enter a value of 0.5 mm for both the wall offset and island offset. After the floor area is finished with a pattern, the finish path for the walls is then generated to remove the 0.5 mm allowance, including the allowance left by the previous iMachining 3D operations. Next, switch to the Contour tab and, in the Start From section, choose Outside. This option enables you to work in a pocket area starting from the outside border and then cutting towards the middle of the pocket. Switch to the Link page to define the parameters of the tool approach and retreat relative to the machined pockets. To control the movement of the tool when it enters and exits the material on the finishing cut of the walls, define the parameters of lead in and lead out. Specify an arc lead in and enter a radius value of 3 mm. For lead out, enable the same as lead in checkbox. At this point, the operation can be calculated and the toolpath can be viewed on the model. Click the Save and Calculate button to add the pocket recognition operation to the CAM tree and calculate the toolpath. Then, click the Simulate button. When the simulation control panel is displayed, click the Play button. The tool approaches and performs finishing of the floors on the uppermost ledge, followed by a finish pass along the walls. The tool steps down to the islands and then progressively to the lower pockets and through hole to remove the 0.24 mm allowance left over from the previous iMachining 3D operations. With each pocket machining, you'll notice that the tool stays away from the walls up to the specified allowance while finishing the floors, and then performs the arc lead-ins for each finish pass along the walls. Using the Exit button, close the simulation control panel. For more information regarding this operation type, refer to the SolidCAM milling help. Close the Pocket Recognition Operation dialog box with the Exit button. At this stage, Step 4 is complete. With just 2 operations, the finishing of the walls and floors of this entire prismatic part is defined. If you have not followed along, apply and practice the procedure shown in these videos to define the finished machining of the prismatic part using the 2.5D milling and automatic feature recognition and machining modules.